Hey Jude,
Hello, hey, hello.
excited to get stuck back into these next sections with you, and yeah,
Yes, they should be a little bit more relaxed than the rapid fire content we got earlier. So feel free to, as we're going through, I would encourage people to ask questions in the Discord, and I will try and answer questions as they come up.
yeah. So
Um,
maybe if you guys can at June and just let it, but please only do it for questions. So it's
yeah, yeah,
they'll
yep,
pop
yep.
up highlighted, and she'll be able to see them. Just so it's a bit more conversational and a bit more real time. With how you doing? Anyway, I'll excuse myself. Please go, June. It's all you.
All right. Thank you very much. All right, hello everyone. We're back, and this session we are going to talk about everything to do with text. Wouldn't it be really nice if we could communicate with people with actual like languages and stuff on screen? We kind of need to talk about how like text works. So I know I did tell everybody like fire up your Visual Studios and your Unreals, but haha, I tricked you. We're gonna look at Goldbolt for a second. And we're gonna have a look at how text works. So if we think about if you do like a really basic string in just C, right? And we just call this hello world, right? And we look at this code and we think about what's going on for a second, right? On the stack, we've declared a pointer to a set of constant characters, and a character in C and C++ is a byte, right? So it is a pointer to a byte. Pointers are like we were doing the pointer math before, where we could increment one to it. So pointers also can act as an unbounded array of bytes, right? So the question that we really have to think about is like where does world exist, right? Now, if we think about what this code's going to do, on the stack we've only got a pointer. Well, a pointer is not large enough to hold an arbitrarily large string. It's just a memory address, right? And we wouldn't want to be like allocating world onto the heap every time we run our function. That wouldn't make that, first of all, wouldn't be very efficient. I mean, it's the same text string every single time. So instead, what the compiler does, when you build your executable or your library, there's basically like two sections to it. There's the executable section, which is where all of your functions, your VFTs, all that sort of stuff gets compiled into the executable section of the library or program. And then there's the data section, and this is where all of your constants and your constant strings get embedded. And when the operating system loads your executable or your program into memory, because it's putting the whole thing into memory, all of those strings that is put in the data section now have memory addresses. And so that's what the memory address of hello gets set to. It gets set to the memory address of where hello is in the data section that's been mapped into memory by the operating system when the application starts up or when the module is loaded. And so that's how we can get string literals in C++, and we're not doing any allocations. We're not doing any like dynamic memory stuff. Like if you use strings in C#, you're going to have string allocations, right? Because they go on the heap. Well, asterisks. I won't go into that when I'm talking about C#. But yeah, so now we've got string literals in C and C++. But as you probably heard me mention, each character is just 1 byte. And so with 8 bits per byte, that means you get 256 possibilities. And you may be familiar with ASCII. There are 256 possibilities in ASCII. But you will notice that this is basically enough to cover like the Latin alphabet, numbers, a few symbols, right? Like in games, when we want to internationalize games, this isn't going to cut it, right? Because we don't have space for accented characters. We don't have space for like Japanese or any other character sets. And we want to make sure that we can localize our games, right? It's also not just enough to just substitute like, oh, let's just say we change ASCII to be some other thing. Well, some languages have more than 256 possible characters. So we literally can't represent all of them in ASCII. And so we don't use ASCII. We use Unicode. You may have heard of Unicode before. You may have heard of UTF-8. UTF-8 is an encoding format which is basically like says, okay, ASCII makes up like 1 byte. So in UTF-8, a character can be anywhere between 1 to 4 bytes, right? So it can be, so like a lot of the ASCII characters that we have, like Latin alphabet, they're just 1 byte. For like higher plane things, so this is things like emojis, for example. emojis are end up being 3 or 4 bytes in a string, right? And so this makes UTF-8 great for storing any possible arbitrary text you could possibly want. You want to store things in a database, you want to store things on the disk, you want to send things over the network. UTF-8 is great because you can store any possible text you would ever possibly need to store. However, in UTF-8, every character can be between 1 to 4 bytes, right? So if we want to get the 4th character, if we think about what that means, we have to know in memory how big every byte before it is, right? We have to actually go and count, like, okay, is the first character 1 or 4 bytes or 3 bytes or 2 bytes, right? To find the actual offset in memory. So it's not efficient for like doing a lot of manipulation of text, right? Because you basically, to do any index inside a UTF-8 string, you have to count all the characters before it and actually process them to figure out where the nth character actually starts. So we don't use UTF-8 really when we want to like be processing text. Instead, in Unreal Engine, we use UTF-16. And UTF-16, every character is 2 bytes, right? So we've talked about ASCII, it's always 1 byte. We talked about UTF-8, it's 1 to 4 bytes, it can vary. We're using UTF-16, everything is 2 bytes. And so this means that, yeah, sure, we store, like if we take this, for example, all these characters, they could all fit in just a single byte. But to make processing the text easier, we just make sure everything is 2 bytes. And that gives us 65,536 possibilities of characters, which is a much larger space. And it gives us the benefit that if we want to know if we want to access the 3rd character, all we have to do is multiply by 2 and we get the memory address, right? Because everything is 2 bytes wide. So we just go 3 times 2 is 6. The 3rd character starts at the 6th byte. And so this makes your text processing much more efficient. I can close this now. I don't need that. All right, cool. So in Unreal Engine, I've just made a C++ project. It's all fairly blank. I've just added this begin play function. And so we want to now start using UTF-16 string literals, right? We want to, because if we just put world in here, right, this is just going to be 8 bits per byte. It's going to be a const char, right? Which, you know, like we can do this, right? But then if we want to pass it into any of the Unreal Engine APIs that are expecting UTF-16, we'd have to convert it on the fly, which is not really efficient, right? What we actually want is for the compiler to store it in UTF-16 from the get-go. So Unreal has a type, it's called teacher, which maps to a 16-bit, it maps to UTF-16. And then, if I can remember the syntax, yeah, cool. The capital L at the start of any string literal will make it a UTF-16, string in the data section of the executable. So now this is a const teacher. Every character is 2 bytes, string literal in memory. Now, you won't actually see this kind of, you won't see the L in a lot of Unreal Engine code. Instead, we use the text macro. This is a preprocessor macro. If we go and look at how it's defined, you will see, oh, well, that's actually way more complicated than I thought. Okay, well, I'm going to trace through all of that. Oh, here we go. You can kind of see up here. If we follow the chain of macros up, you can see that it's putting the L in front of it for us. And the reason that we do that, the reason that we use this macro is so that if you want to change how all of the strings are, all the static strings are encoded inside the game, you can just do that at the compiler level by changing the defines, right? You don't have to go and find every single place in the engine and every single place in your game where you put this L constant and then change it to whatever you want. The macro does it for you. So this is how we declare constant like string literals in Unreal Engine C++ code. We use a text macro. It's a const teacher pointer because it is a pointer to a teacher, the first teacher it is in the list, but it's technically an unbounded array of teachers. And they're constant because this is going to be in the data section of the executable, so you can't modify it, right? A quick side note that I didn't actually cover on earlier, though. is that the way that strings, or the way that string literals in C get encoded, right? Because if you think about, where's the it's like if you think about this code, for example, and we want to print out this. Yeah, cool. I was worried there for a second. If we want to print this out, how does the how does the code know where the string ends, right? Like in this case, we're passing in hello and it's world, but it could be anything, right? The way it works is that when this gets encoded into the data section, there is actually a null byte that sits at the end, which you can encode with a /0. And if we look at the ASCII table, this is not the number 0, which has an ASCII value of 48. This is null value of 0, which is just the null character, and it signifies the end of a string. So whenever you're processing static string constants in C or C++, they're always got this invisible null character added at the end, so that any code that's coming along, it can be like, okay, cool, I'm going to go through the characters and find out where the end of the string is. Cool. I'm going to put trip here. So now we have string literals. We know how they get into memory. We know how the pointers are available at runtime. How can we manipulate these, right? Because this is not particularly useful just yet in terms of like, we want to modify strings or print strings and do anything like that. So like we were using the standard library string class before in some of the demos we were doing in Godbolt, Unreal has a string class and is called FString. And FString takes a UTF-8 string if you want to initialize one. You can do it any way you like. You can do it like that to set the constructor on a variable. You can assign it like this. However you like. It's just a generic string class that lets you then treat strings as like mutable things, and you can perform different operations on it. This is also what provides you like your string API. So like on hello, right, we can't really do anything, right? It's just a raw block of memory bytes that happens to be loaded into memory by the operating system. You can't do anything with it. But we can do stuff on string. But this is where we get all of our functions that are actually useful. You've got things like contains. You've got like, I think this is that's creating an empty string. There's like is empty. If you want to do substrings, they're not called. It's not called substring. I'll just give you a hint right now. It's actually called mid, which is probably a bit weird if you're not used to. If you've never done VB6 before, you'll be like, why is it called mid? This is a naming convention from like VB6, I believe. So instead of substring, if you want to do substrings, it's called mid, and then it's the usual sort of like substring parameters. So great. Now we have UTF-16. Sorry, strings. We can manipulate them. If we want to assemble them together, like if we want to use if we want to print formatted strings, I'll show you what that looks like now. We can do this is how you interpolate stuff, right? So like I want a string, I want an int, I want a double. Let's use a double, and we want to put this string at the start, right? So string. Let's just do an int. What's 100, and we want a double. Let's just do 30, right? Now this is not going to work. Everything looks fine. Visual Studio thinks it's fine, but this is actually not going to compile. And the reason is that printf takes, for a string parameter, it takes a tchar pointer, not an f string, right? So, and the reason for this is, well, I won't try to guess as the specific reason for this particular function, but if you think about it, let's say we wanted to interpolate some other constant here, right? We don't want to have to convert that to an f string, because that's going to call the f string constructor. It's going to allocate memory potentially on the heap, just to pass in a constant into a function that doesn't actually need to modify this value, right? It just needs to have the raw bytes that it can then interpolate into whatever it's doing. And so when we pass an existing string into printf, oopsies, come on, select for me. We actually need to get the tchar pointer, right? This is not a tchar pointer at the moment. It is an f string. So what we're going to do is we are going to use the dereference operator. Now, I know earlier I talked about how the dereference operator is used to get is how do you take pointers and you convert them and you basically turn them into references. Sorry, I'm getting added. We use the dereference operator to turn pointers into the things that are actually inside them, right, and get a reference out. But C++ lets you do operator overloading. So in C++, you can overload almost any operator you want on any class you want. So if we, to make an example, right, let's go make a class real quick. And I was like, gonna chuck this in here. If I like dereference this, like, Visual Studio, you're gonna give me, we'll go back to Godbolt. Well, this is not having a fun time. Class, just an empty class, whatever. We're gonna make one of these. We'd like try and dereference it. It's gonna be like no match for the dereference operator, like because it doesn't know how to dereference this class. It's not a pointer. It doesn't know what to do. But in finally, Visual Studio got up to date. But you can overload any operator you want. So hopefully this works. Yeah, cool. So now we are inside. We're looking at the definition of FString. If I scroll all the way up the top here, you can see this. You can see the constructors for FString. You see the class FString definition here. We go down here. This is where our operator overload for the dereference operator is. And you can see that the dereference operator here has been overloaded to return a teacher or constant teacher pointer. And what it's doing is it's basically saying, okay, if the string has data, give me the pointer to the string's internal memory where it's actually storing its string data. Otherwise, just give me a pointer to an empty string if presumably empty strings are optimized so that they don't actually do any allocations, which makes a lot of sense if you think about it. There's no reason to do allocations for empty strings because they're just empty. But just return the pointer to like the actual like data array that's being held inside this string. And so if we want to pass a string into printf, we just dereference the fstring first. This will be a teacher pointer, which will then work with the printf call. I don't know what that's complaining about. It's probably just because I've got some unused stuff going on. Cool. Oh, it's probably because the printf. So so printf here is unlike when we were doing stuff in Godbolt and we were using printf and it was printing stuff out to the console. Printf here does not print it out to the console. This is actually just a formatting function. So this actually returns a string. Yeah, I wonder if this works. Yeah, cool, this works. This probably has no discard on it because if you think about it, since this is returning the interpolated string, you don't really want to be making a call to printf, which is, if you think about it, is probably going to be, I don't want to use the term expensive, like in terms of CPU calls, but it's not a lightweight operation. You don't really want to be doing this and then just discarding the result because that's just completely pointless. So that's probably why that attribute's on there, to make sure you assign it to something. Cool, we've gone through fstrings. All right. Cool. So let's talk about FName. So you'll see FName used in a few places. It's not super used, but it is used in a few places. And basically, FNames are case-insensitive strings that can also, in some cases, just be represented by a single integer value. And the reason these are useful is because of networking. If we want to pass a common, well-defined name, and there's a bunch of them here, like if you go name underscore, you'll see all of these constants defined. These are all FNames. If we want to pass this over the network, it's going to be a lot more efficient for us to pass an integer that this happens to be mapped to, which in this case, color is mapped to 62, than passing the whole text block of color, right? Because that's just going to be, it's going to be network traffic we don't want to send. So instead, we have an FName, which is basically a way of storing. I like to think of them as like unbound. It's like an unbounded enumeration, right? If you have an enumeration and you know all the values, you can use an enumeration and have like 0 to 10 or whatever as the underlying way of representing that value. If you've got unbounded enum, then you can use this as a more optimized representation for sending things over the network. Things to know about them, as I said, they're case insensitive. So, you know, like a name that's spelled default is the same as default, right? And you'll see them used in a few APIs that are related to networking. Yeah, I think that's pretty much covering FNames. They're not like super common, but you will see them used in a few places. So cool. We've got text. We've got strings that we can put international characters in. But imagine that we ship a game with this code right now, right? Like, let's say we ship a game with code, and then it comes along and we want to like translate the game, and well, now we have a problem, right? Because now we've got like world is just this string literal in C++. Like, how do we replace it? Like, how do we translate it, right? Without the translators having to go in and be like, I'm going to change C++ code. And you know, obviously, we don't want our translators to have to do that. We kind of want to be able to substitute all of our strings. So this is where FText comes in. So FText, I'm going to call it a different variable name. And then what we're going to do is we're going to use these macros. Now, there's two macros. There's ns_loctext and there's loctext. Loctext, basically, loctext is you would. I'm not going to do it right now, but you use loctext when you define the namespace for the localization at the top of the file. And there's a convention for this, and I can't remember off the top of my head, so I'm just going to use ns_loctext. I use ns_loctext in all of in all my plugin code. I just use ns_loctext. I don't bother with the loctext stuff because I typically find that doing the whole like, cool, I'm going to define, you know, the localization namespace as blah, whatever, and then having to undef it at the end, and then you've got like 2 pieces of localized text in the whole C++ file. And it's like, that was really pointless. Like, I should have just put the literal in there, whatever. I should have just used ns_loctext. So that's what I do. So we might give the namespace, for example, we've put our project test project, so we're going to call it. We're going to use the text. Yeah, someone in the chat just is, yeah. This is what it's called, loctext _ namespace, and you can define it as whatever, and then undef, and then you can just use loctext. I'm not going to do that now, but yeah, that's how you can do that. So we're going to use the test project namespace because we are in the test project module. This is primarily so that, like, if you have plugins that are using localization, well, the plugin localization keys, when we use these keys here, won't conflict with your game plugins, right? And won't conflict with the engine plugins, and so on and so forth. Somebody in the chat just asked, only hard-coded names are translated as numbers over the network, right? Custom FNames will be moved as is, and they are more costly. I believe the answer is yes to that question. Basically, because it's not predefined on both sides, your only option is to basically send the name. It might send a hash of the name, actually. That might be possible. It might send actually just like, it might hash the case-insensitive name, get some sort of hash, and then just send the hash over. No, it can't do that, because if you receive a name on the receiving side and you don't know, and you've never seen that name before, there's no way to turn the hash back into the actual FName. Yeah, I don't think you can. Yeah, I think it has to send the whole thing. Another person asked, how would I add my own strings to the FName lookup table? I believe that the hard-coded list of names is just it's just hard-coded the engine, I believe. You might be able to add things on here if you modify the engine. I've never added my own custom name constant, but I would say that you'd probably have to build the engine from source and add it in here to do that. Typically, I think really, if you're running into a situation where you're like, wow, I really need this FName on the network to be like transmitted more optimally, and like adding it to here would be an optimization. There's probably other optimizations you can do first, like changing the FName out to like your own enum before you go and modify the engine or something like that. I would say that there would be other strategies you could use before you go to the effort of like, cool, I'm going to call register name and then recompile the engine that you could use to save on that. If you were transmitting the name, because you'd have to be transmitting the name like dozens of times every frame. Like you'd really have to sort of reach the high end for that to be sort of an issue, I think. Cool. So back to text. So we've got NSLog text. So we've got the namespace, so we don't conflict. Then we're going to have our key, which is going to be what, which is going to be what the translators key the translations on. So in this case, we might call it, hello world, and then we might set the the English version or the default localization for the string to be hello world. Cool. And now we've got our text. And if we wanted to like interpolate that, we could do a dot, I think it's, t dot to string. You probably actually wouldn't use string printf for this. You would want to do FText format. Yeah, I'm remembering it now. I believe. Good Lord, I can't remember FText format. There is an FText format function which takes text parameters and then also returns text, and then this allows you to localize the format string as well, I believe. I don't know FText FText format off the top of my head. There's a blueprint equivalent of this as well, as there is with a lot of things. That again helps you make sure that you can localize all the text in your game that's possibly user facing. If any string is going to end up in front of a user, you want it to be using FText and you want it to be localizable. You don't want to use FString. You want to use FString in cases where you're assembling like text data that you might then send over the network, or things that are programmatically understood, or like debug logs. I mean, you can make your debug logs FString, right? You don't have to localize those. So, I just realized I've lost my timer. Okay, we're almost on time. If now that we're using NSLog text, yeah, someone in chat has helpfully put the FText format stuff in there. So have a look at the chat for how FText format works. Now that we're using NSLog text, the way that this gets into the localization system, and I'm not going to launch Unreal right now because we've only got about 3 minutes left, is there is a localization section of the editor. And what this can actually do is it will actually scan all of your source code for this macro, and it will generate all of the entries in the localization table with the parameters that you've set here. And then at runtime, this macro expands out to something that is going to be able to use that localization and therefore substitute in the correct FText value at runtime so that your string is correctly localized. And that is going to put a wrap on the text workshop session. If we've got any other questions, I will take them now. I do apologize for my throat. If I'm coughing, it's because I'm talking lots.
Yeah, no, sorry, Drew, I was going to jump in and say hello. Yeah, no, you're doing great. Hello. I apologize for putting this undue strain on you. Yeah, no, that's super interesting. Yeah, I guess now we're getting more into the Unreal stuff. I'm just like, wow, like I guess like this is really great information. I'm learning a lot of really good tips here. Yeah, I think we've got any questions specifically. So it seems like people.